All right. Well, thank you all for being here. I am so excited. A huge thank you to all of you uh, for being here at the first California Water Data Consortium's Data for Lunch. I'm Tara Moran, CEO of the California Water Data Consortium. And before we get started today, just wanted to remind you all that we are recording today's session and it will be available on our website after the meeting, along with our presenters' PowerPoint presentation. So for those of you who may not be familiar with the California Water Data Consortium, we were founded in 2019 to support implementation of the Open and Transparent Water Data Act. And all of you well know that data really is at the heart of informed water management in California and beyond. And so it's with active involvement with state agencies, NGOs, and the private sector that we provide a neutral space for ongoing dialogue and collaboration to advance the use and accessibility of water data for data-informed water management decisions for a water resilient future for all Californians. And part of the process of advancing these goals is really learning about, understanding, and connecting with new and developing technologies and data collection methods so that we can understand how the field is evolving and the potential application of these technologies in our own work and decision-making processes. And that really is the goal of our Data for Lunch series. It's to learn about new and innovative water-related data methods and technologies, but also to provide a venue for all of us to learn from and connect with one another. And so I'm absolutely thrilled to have Tom Painter from Airborne Snow Observatories with us here today to kick off our Data for Lunch series. Snow provides about a third of California's water supply on an annual basis. So improved understanding and forecasting of that resource, as well as a whole host of other information that's available as a result of Tom's work, is so important for long-term water management in California, particularly under a changing climate. So before I hand things off to Martha Davis, one of the consortium steering committee members, who's going to formally introduce Tom Painter, I just have a couple of housekeeping items. Firstly, if you have suggestions of other Data for Lunch topics, please reach out to myself or Amanda. Our information will be in the chat or on the consortium's website. After the introduction, Tom will give, let me lay out what the actual presentation format will be. After an introduction, Tom will give a 25 to 30-minute presentation. After that, we'll have time for questions, facilitated questions, which Martha and I will be moderating. So please drop them in the chat and be sure to include your name and affiliation. And then after that, Tom has generously said that he will stay on for another sort of half an hour after the more formal presentation and discussion so that we can have a less formal sort of discussion back and forth. So with that, I'm going to hand things over to Martha to introduce our today's speaker. Thank you.
And I want to join Tara in welcoming all of you to our new Data for Lunch Brown Bag series. I can see the numbers kicking up. So we've got a great group for Tom. And I'm particularly pleased to introduce Tom Painter as our kickoff speaker. I'm aware of his work in the Sierras and through the Eastern Sierra. I've had a chance to talk with his son, listen to the dogs. You've got a great life, Tom. You all have Tom's bio in your meeting invite. Just briefly, by training, Tom is a snow hydrologist and a remote sensing specialist. He was recruited back in 2010 by NASA Jet Propulsion Laboratory to develop a remote sensing program for snowpack monitoring. And within 8 years of that time when he was recruited, he was receiving nationwide recognition and awards for his snow observation program. For all the accolades that Tom and his team have collected, the most impressive come from these two sources. First is DWR's renowned Frank Gerke, who said that Tom's work is the next generation technology for making real-time assessments of snowpack and runoff. And the second is from the water agencies with whom he has worked, who've declared, now this is data that we can use, the highest praise that anybody can receive. Tom, thank you for joining us today, and we look forward not only to hearing about your cutting-edge, real-time snow monitoring program, but also about the multiple ways in which your data can be used in California for many other water and resource management applications. So with that, I'm turning it over to you.
Great. Thank you, Martha. And thank you, Tara, as well. I'm honored to be first in the line here, and I'm looking forward to listening to the next series of talks that are going to be coming. There are so many people that are actually on the call right now that I would want to thank, that it would consume all of the time, I think, to thank them. But I want to highlight my team at ASO Inc. And they were previously with me at the NASA Jet Propulsion Laboratory. Jeff Deems, who has been with the National Snow and Ice Data Center, and Joe Boardman, who was the one who fixed the M-cubed imaging spectrometer, the moon mineralogy mission that helped to discover water on the moon, to confirm what was in the rocks that Neil Armstrong and Buzz Aldrin brought back, and many others. We have a team that's very connected to data quality, and data issues coming from. I used to be at the National Snow and Ice Data Center. Jeff is still there. We have spouses that are with the Earth Science Information Providers. Annie Burgess, who's married to Evan Burgess, who is our lead data scientist. So we're really immersed in it. I would argue that the rest of the team is far better versed in it than I am. But I've asked some of them to be here today to help field some of those additional questions. So let me see if I can get the advanced. So as Martha described, I'm going to talk about the Airborne Snow Observatory and the successes that we've had and the direction forward. And then the broad scope of the use of the repeat ASO data beyond simply snowpack, and then a preliminary view into our data archival and distribution system that we're working on toward supporting DWR, and then potentially helping to set the framework for the Department of Conservation and their California LiDAR program, given that there's a fair bit of redundancy in what we're doing for DWR. So here we go. So I'm gonna jump to the punchline really quickly, just to show you what it is that we do and what the excitement has been about. We are mapping the snowpack wall to wall, so every square meter of snowpack is touched with our lasers and our spectrometers, and we fly as rapidly as we can. And from up here in the northern part of the Tuolumne, and we're actually extending this this year. In fact, in a few minutes, I'm going to show you the active flight that's going on right now, down through the Merced and the San Joaquin to the Kings in this particular map, and then this year we're adding in the Cahuilla as well. And then we've also been spilling over into the Mono Basin and into the Owens as well. So with these mapping results, the forecasting, the seasonal forecasting, it was, to us, even though we knew there was going to be value, we were shocked by the accuracy of the ability to forecast the measured total inflow. So the seasonal flow from the date of an ASO acquisition out through the end of July. So an updated AJRO, April through July runoff. And ultimately what we've discovered that this has led to is looking at these traditional forecasts that have accuracies that run up. Sometimes they're up here in the 90%. Sometimes they're down around 50%. And the unfortunate part is that generally you don't know until after the season is over what that accuracy is going to be with that more traditional forecast. Whereas with the ASO measurements, what we found is that having that very tight knowledge of the snowpack, in particular in these snow-dominated systems, is absolutely critical to getting that much higher accuracy, as well as running up this nonlinear value curve. So let me move ahead. So I think all of you are aware of this, and I just alluded to it. The forecasting that's been done over the decades, based on the snow courses and the snow pillows. In some years, the accuracy is pretty good, less than 20% errors, and that's about half of the time. 1 in 5 years, those forecasts, though, well, actually half of those years, of course, the forecast errors are larger than 20% in magnitude, and 1 in 5 years, they're larger than 40% in magnitude. And what we're running into now with our changing climate is these empirical approaches that we've had are becoming less reliable because of the transients in the climate and the transients in the hydroclimate. And if you look back here to the 1950s, we're starting to see a climb in the standard deviation from year to year. So those highs getting higher, the lows getting lower, which is consistent with what we know of the modeling of hydroclimate and climate. So how do we make the water supply forecasting more robust? Well, being able to move to physically based modeling is really where we need to go, so that we're not having to rely on a past that is no longer tightly tethered to the climate that we're in presently. And where this goes, even if we weren't going through a changing climate, we have a greater population and more demand on the water supply, and therefore year to year variability in those forecasts affects more and more people. It affects more and more structures. And so every year matters now. And so we have to attack every year and get it right in every year. So the Airborne Snow Observatory, this is an overview of what we built and what we're after. So we're after the two most important snow properties to forecast runoff volume and timing. First is the snow water equivalent. The other is snow albedo, or the reflectivity, and that modulates the absorbed solar radiation, and that drives about 90 to 95% of warming and melting of snowpack. The snow water equivalent comes through a combination of our snow depth measurement, and then the snow density, which comes from modeling and constraint on that modeling from the field observations. So we don't want the field measurements to go away at all. We absolutely need those moving forward. The snow albedo comes from an imaging spectrometer in the visible through near-infrared wavelengths. And then we have the physical modeling that ties all of this together. We also have in our operations, through the time at NASA, many of the more seasoned airborne programs were telling us, you guys are crazy if you think you're gonna fly at 22,000 feet on oxygen and do that for 6 hours day after day. And fortunately, we had a lot of mountaineers and skiers who just couldn't get enough looking out the window at the mountains, and they also had experience in the backcountry, and so they were accustomed to being a bit hypoxic and suffering a bit in the plane. Fortunately, we've gotten things to where the suffering is now minimized. So we also have high altitude and snowpack specific flight procedures. So it's not just a typical LiDAR survey where you go out when it's perfect. We have to get the data to our customers when they need it. So for instance, we started flying the Tuolumne yesterday because Wes Moynier, Jason Carkeet, who are on the call, they need their information by Monday for some important decisions that are coming up. And so being able to optimize that flying and adapt to cloud cover that pops up now and again is absolutely critical. The other aspect of that is the rapid product turnaround. And we were also told, you guys are crazy if you think you're going to be able to turn the products around that quickly being 24 to 72 hours. Usually a LiDAR and spectrometer survey, they'll take a few months to wade through the data, wade through the point clouds, et cetera, and finally arrive at a clean data set. And this team built an amazing processing chain, which we now, as ASO Inc., have the exclusive software license on from JPL to really be able to carry that forward. And in this photo, we've got the LiDAR up front, which is what we use to measure the snow depth. It's a laser altimeter, and then right behind it is the imaging spectrometer. Okay, so this is how we operate here. This is how we fly a basin, is essentially just going and mowing back and forth. So it looks like the field at Fenway Park. And then what that results in is a snow depth map that looks something like this. We start at a 3-meter resolution, and then we coarsen that up to 50-meter resolution, which is where we multiply by the density field from the iSnowBow model from the USDA Ag Research Service that we've been working with from the beginning. And then that ultimately gives us this spatial distribution of snow water equivalent at 50-meter resolution. And so our first acquisition was April 3rd, 2013. And before that, there had never been, at least on planet Earth, a mapping of this scale for a complete mountain basin for snow water equivalent. So look at that with wonder and excitement. So let me jump this ahead. What ASO is flight processing modeling, and then the piece that we're putting together right now is the SaaS, which is software as a service. And so I've just described the flight. The processing is through that software that we developed at NASA with the rapid turnaround, and it's not just the depth or the SWE and albedo, but also snow grain size and radiative forcing, so how much additional sunlight is being absorbed by dust, et cetera. And then vegetation products, which I'll get to in a second. And then this feeds into our modeling, which then feeds back to giving us the snow water equivalent. But also we're working with NCAR, the National Center for Atmospheric Research, on the WRF hydro model. And I'll describe that here in a second. But we also have the feed coming over to the DWR Bulletin 120 and the River Forecast Centers. And this then ultimately gets fed on into the visualization, analysis, and the decision making. Now, this was to get me to move out really quickly to show you ASO flying right now. Let me make sure this is updated. Okay, there we go. And actually, so it looks like they rounded out that survey, and the plane has come back and should be landed right about now. So this was a survey going on this morning over the Tuolumne, and we yesterday afternoon had picked up the high country here across to the Lyle Fork. So for those of you who want to keep track, use Flight Radar 24. That's the one we prefer. There's also Flight Aware. And the aircraft is N441CJ. And you'll also be able to check it out on Twitter and Instagram. We'll be posting flights on there as well. All right, now let me go back to PowerPoint. Okay, now let me skip that, but let me show you. This is actually what they just did, except not video. This is video from a few years ago, but this is coming back to the Mammoth Airport. Across the San Joaquin, here, Banner and Ritter right there in the minarets. And then there's Mammoth Mountain, dead center, and over into the Owens. And you can see Crowley there, and then coming across the hot springs for those of you who know the area, and then banking in here. And this was a pretty straight on landing. There have been many times with the crosswind that I'm looking out the side windows straight down the runway. So it's rather exciting. So the program evolution, we had our first snow-free flights, the baseline flights in 2012, first snow on in 2013. Again, in that year, we started with the Tuolumne and then acquisitions in Colorado. And then we had this growth in the state of California, growth in the state of Colorado. We added basins in Switzerland and expanded in the Southern Sierra. And an exciting development was the California Senate Bill 487, which was the original pathway to the full state coverage for the program. And that was going to run from the Kern, all the way north up to the Sacramento and then across to the Trinity. In 2019, NASA finally said, look, you guys have become sufficiently operational that you're not doing research as much anymore. It's time for this to migrate out. And so we created the Airborne Snow Observatories Incorporated as a public benefit corporation. And then in 2020, started our strategic partnership with Esri, the GIS, the world leading GIS company. And then we started last season as our first as ASO Inc. All right, let's look at some of the data really quickly. This is from the East River in the Gunnison in Colorado, and Crested Butte ski area is just to the right of center, and the town of Crested Butte is there in the middle. These are fascinating data where this is the 3-meter snow depth data. You can see so when you look at this, you see, okay, it's lower snowfall down low, higher snowfall up high. Okay, what's the big deal with the spatial variability? Well, you don't tend to know how much more up at the higher elevations, and likewise, you don't know the spatial variability in the middle to lower elevations as well from just snow pillows and snow courses. You can see the dramatic avalanching here off of this southwest face, and dramatic wind scouring and redeposition over into these cirques. Massive avalanche down into this gully. This was a really big avalanche year in Colorado. And to highlight the data importance here, this on June 10th, 2019, and showing the contour line of the elevation of the highest snow station in the watershed. All right, so there's a little bit that was trickling out here and there, but for the most part, the non-trivial amount of snowpack remains above the ability to make those measurements. And so that really reinforces the importance of having these airborne measurements. And we get questions quite a bit. Okay, ASO, well, we've seen all these interpolated products out there. This is likely to just have a marginal effect on our forecasting. This is not of that ilk. This is a direct measurement. And so this is the first highly accurate, spatially complete measurement of snow depth, snow water equivalent, and snow albedo. Our depth accuracies are plus or minus a centimeter at a 50-meter grid cell. Our density, our snow densities are plus or minus 3 to 6% at 50 meters, and our total basin snow water equivalent accuracy is in the 1 to 2% range across the basin. And it's really bumped that forecasting accuracy up considerably. And in particular, for what is the minimum inflow that I'm going to have into my reservoir or through my river stretch. The forecast improvement, we've done a study with the California Cooperative Snow Survey partners, and their best estimate for the statewide program is that it will result in an average year of about of more than $600 million, which is a return on investment of about 40 to 1. That is for water supply alone and doesn't include hydroelectric recharge, ecosystem, operational flexibility, et cetera. So when you start to include those, then you start to push above the $1 billion a year value, marginal value from these measurements. This just shows how persistent that rigor is in the measured inflow versus the ASO snow water equivalent prediction, and that the snowpack realization. This is in the Tuolumne, this is Rush Creek over in Mono Basin, Mammoth Creek right here behind our house, and the Merced. And I can show you those endlessly. This is then the assimilation, the spatially distributed assimilation by the Hetch Hetchy water and power PRMS model, which is a physically based model leveraging the ASO data. This is a result from this last year. The red and pink is the PRMS model for inflows in the absence of the ASO data. The blue is with the ASO data, and the black trace here is the observation. This is just one example here in the Sierra of that kind of updating. Then we're also working with the river forecast centers with the National Weather Service. In particular, we've been working with the Colorado Basin River Forecast Center, just because we've been working with them for many years on some of the multispectral data as well from satellite. And this is on the Taylor stretch in the Gunnison. The volume here was 29.1 thousand acre feet for the April through July runoff. Their unmodified forecast, they were off by about 21%. And then with these offline modeling efforts with ASO, with a March update and a May update, it brought that forecast into the 4 to 3% uncertainty. And actually, if they used both of those, it brought it to nearly spot on. And then, as I mentioned, we're working with the WRF Hydro team at the National Center for Atmospheric Research on assimilation. And WRF Hydro is the basis for the National Water Model, but you can also run it at a much finer resolution and specific to the mountains. And so these are the ensemble forecasts in the absence of ASO. And this is then with a May update to the model. And the median, you can see, disappears. That white trace disappears behind the observed. So it's working well. Now on the value of this information and some of the case studies, in the San Joaquin, of course, the restoration program that's going on there, the ASO data have become critical for them in achieving their flow factors and the summer supply reliability. And then a great example on the water supply side from 2019 was in the Kings, when the Bulletin 120 and the California Nevada River Forecast Center forecasts we're coming in lower than what ASO was finding with our observations through the Kings, and so even with the 10% exceedance value here of the high value of 2.3 million acre feet, we were still pulling that higher. And what this allowed Steve Haugen and Matt Meadows to do with the Kings River Water Association was get out in front of a flood call and bringing in the Army Corps. And they were able to start releasing water early based on our pulling them to the 10% exceedance from the River Forecast Center. And they were able to save about 100,000 acre feet, or get that to their users and keep it in the service area. And their best estimate on that was about 100 million in water that they were able to save for their users. Hydroelectric optimization is really just starting with the ASO data. This is an analysis from West Moynier with Turlock Irrigation District, and I highlight this this plot in the lower left. So hydroelectric optimization would be really, really easy if every year was the same, if we knew every year's acre feet. But we don't. The average year almost never happens, and they're rather stochastic with their clustering, and so being able to optimize is absolutely critical. And just looking at the average case, in particular for the Don Pedro, Wes's best, very conservative, as he indicates here, marginal value of the ASO information for planning resources ahead of time, knowing the amount of water that's up there that's not known, and the amount that was in fact not known, and then the operational dynamics and planning for the unseen, and then market opportunity. He came to a number of about 1.5 million, which is markedly more. That alone, independent of water supply, that's markedly more than what the full build out program will be for just the Tuolumne, by about a factor of 2. So let me, and that itself arrives at about a 10% efficiency gain in terms of the hydroelectric alone with Don Pedro. All right. Just getting into some of the details. So ASO is expressed, not explicitly, but as emerging technologies in the 2020 water resilience portfolio. Likewise, here's Senate Bill 487 from Senator Caballero, which looks to be headed back to life in this year, hopefully for implementation next year. But we also saw federal legislation, HR 2, which ultimately got woven into the omnibus bill and passed back in late December, I think it was. And this includes about 15 million across 5 years for seed funding for building out ASO programs throughout the Western US. And then there was, prior to that, was the Josh Harder's and Senator Feinstein's, Congressman Harder's and Senator Feinstein's bill. And I gotta say, I was really excited for our team that Senator Feinstein said Airborne Snow Observatory on the Senate floor. Wish I'd been there for that. All right, so let me talk about the broader use of the ASO data. So first of all, I want to highlight the creek fire acquisitions that we did back in the late fall after the fire went out. This is showing the pre-fire vegetation height from our snow-free acquisition in 2016, and then the updated acquisition in early December. And then this is the veg height differences, and you can see the most intense forest burning there. So these data are going to be available here pretty soon, and we've already done the delivery to DWR. The other thing that I want to highlight, so I realize I didn't say yet what that SB 487 program and that full build out will look like. So I mentioned the spatial extent, but I didn't mention the temporal. So the temporal is looking at approximately April, May, April, February, March, April 1 to coincide with the snow surveys, and then biweekly thereafter. And so we're looking at approximately 10 acquisitions in each year. In big years, we'll probably do more. In smaller years, we'll do fewer. But that average year heads out to the beginning of July. And what this allows, then, we don't fly at high point density with the lasers because we want to cover a lot of area. So with our 1 point per square meter acquisitions, this is what the forest looks like in an oblique shot. This is what it looks like looking down, and the color is according to elevation. So you can see the meadows, the openings in the canopy, and you can see the trees, but it's not a very carefully characterized forest canopy. But by fusing the time series over the year, then we have the ability to fuse this into an approximately 15 point per square meter acquisition. Now, it's not a simultaneous acquisition, so there's a little bit of uncertainty there. Likewise, you've got growth that's going on during that time, but this at least is a filler in between the times when you have a very high point density acquisition, akin to what Nate Roth is going to be leading with the California LiDAR program to really carefully characterize those forests. So these data will be available on an annual basis. With the spectrometer, we have the ability to look at not only what the LiDAR is showing us in terms of mortality and loss of biomass, but also stresses that are coming before that biomass is gone, and to really be able to tell the difference between healthy vegetation and water stressed or beetle stressed vegetation. And you can see that that analysis over here on the right. We also are working with glaciologists, and in particular, Greg Stock, who's the park geologist for Yosemite. This is showing the Lyell Glacier from Israel Russell's work back in the late 1800s. We've been using the LiDAR data to map the topography of the bare ice. And Greg has been working then on tying this, these high resolution and very accurate measurements all the way back through the surveys to the measurements from John Muir. So be looking for that paper when it comes out. That's going to be, it's a really exciting one, and especially for data geeks like all of us. The other thing is the ability to look at communities that are in those mountain systems, and to be able to look at snow depth across those, looking at trails for the Forest Service and state parks, knowing when campgrounds are melting out, and looking at trail snow depths for when it is that they should start heading out and getting those trails ready for the tourists. And likewise for Caltrans and for recreationalists, including the snow plowing that goes on in Yosemite on the Tioga Road. They use our data to determine what they're looking at for snow depths and progress that they're making as they plow that through. Okay, so the final piece of this is the ASO data and visualization system that I mentioned that we're building with Esri, hand in glove with them, and so this is to be a dynamic data portal. It's one that should be hung off of, well, actually it'll be pointed to by CDEC, the California Data Exchange, because it's generally a huge step up in data volumes and data types, all the way from the enormous rasters to the point clouds, the raw point cloud data. And that's why we think it will likewise be valuable for Department of Conservation for the California LiDAR program. And it's going to give the access to the public, and then ultimately allow subsetting and download, data exploration and visualization tools, temporal comparisons, and then we'll also have some client-driven customization and optimization. This is just the present preliminary build-out front page that we have from our work with Esri, and but this is really more of what it's going to look like. So you see the time series down here below. What you're going to be able to do is go to click on, okay, when was the acquisition? And when you click here, say on acquisition 4, you will see the observations from ASO. If you click on, say, May 14th, well, you'll see the model results from that date as they have been constrained by the ASO data. And then likewise, we're going to have the forecasted snowpack moving forward. So today is June 2nd, say, that you're looking at this, and you'll have the ability to look at that snowpack forecast. And likewise with various ensembles in the modeling, and to be able to look at the data values, and also to be able to look at the spatially distributed uncertainties. The other thing that we're building will be these distillations, so the time series of total snow water equivalent, with the ASO updates along here, the hypsometric distribution of snowpack, and then a rose chart with aspect and elevation, to really give that ability to understand what's going on with the snowpack. And likewise, I mentioned the differencing. So we can pick and say, okay, I want to look at how I'm doing here on June 4th relative to April 15th. What's the hypsometry there? What's the rose chart here? And then what's the spatial distribution at this high resolution across the domain? All right, and then getting at the point clouds. This is a point cloud representation from, I think this is in the Creek Fire scar, and that's an oblique view, and then likewise the cross section of the point cloud itself. So all of these components are going to be there for the ability to visualize them, and then also to be able to download those data. So I left almost 15 minutes for discussion, and Jeff Deems is one of our co-founders, and the website is right here, airbornesnowobservatories.com. And I will stop there and open it up for questions.
So before we turn to questions, I just want to say a huge thank you to Tom for being here today and providing such a incredible illustration of the value of data and the value of high quality, near real time data to touch on so many different aspects of our lives. Everything from water supply to hydroelectric optimization to transportation to changes in vegetation and the like. So just a wonderful illustration of both the value of that data, but also how this process has evolved through time and how it's really supporting both California, but well beyond that. So thank you for that.
Thank you.
So I think what we'll do is we have, as Tom said, just shy of 15 minutes. So what I'd like to do is have sort of facilitated discussion in this portion of the presentation. So just if you have questions, please drop them into the chat. Martha and I will pin those for Tom. And then he has generously offered to stay on after 1 o'clock. And so we'll end this at about 5 minutes to 1, and then we'll transition to just an open forum where people can ask Tom questions and have more of a discussion style forum. So Tom, we had a couple of questions actually come in advance that touch on a few of the case studies that you had actually flagged. So I'm going to read one from Peter Dreckmeyer from Tuolumne River Trust, who asked, water agencies have held back on releasing water from dams due to uncertainty about how much water would be available, which has ultimately impacted the timing, and they're essentially not well timed for juvenile fish rearing and outmigration. And so how can this help to improve the uncertainty and ultimately ensure that we see more protection for both human uses as well as the environment moving forward? And you touched on this in sort of the San Joaquin, but I'd love to hear about that for the Tuolumne.
Yeah, there's a great example in the Tuolumne. So for everybody out there, the number one priority for the Hetch Hetchy reservoir is water supply. Hydroelectric comes after that, and then environmental flows as well come afterwards. And I know that Wes and Jason Carkeet are on here, and I'm guessing somebody from Hetch Hetchy might be as well. So please add to what I'm saying. But what's been really exciting is that the Hetch Hetchy team has been able to start working more intimately with the National Park Service towards getting to those environmental flows. And so how can it do that? Well, 2017 and 2019 were great examples of this, in that we had early snowpack accumulation and heavy accumulation. And by knowing, say, that you've got 100,000 acre feet or 200 or 400,000 acre feet beyond what you need to fill the reservoir, based on that empirical relationship, that scatter plot that I showed, if you know you have that, well, then you can start working with the Park Service on achieving a more normal flow beneath the dam. And so getting at those environmental flows, doing it earlier in the year, and that also has the capacity to work towards the hydroelectric operation as well. But with these dammed systems, getting to environmental flows and more realistic flows really relies heavily on a solid quantification of your supply. And this, for us, this has been really exciting to see the enabling of that relationship and that capacity.
Tom, if I can jump in here, there was a similar question from Patrick O'Connell about applications of ASO for improving stream flows to the San Joaquin River, i.e. the restoration project. So do you have anything you'd want to add with respect to that system?
Well, the San Joaquin was our first basin to so it was through Friant and Bureau of Reclamation and the San Joaquin River Restoration Program that we received our non-NASA on non-state of California funding. And that was based on their peering over into other basins that we were flying. And so I'm not sure if Chad Moore is on here. I know Peter is, but the value has really shown itself for that river restoration program for very similar applications.
So Tom, there are several questions about how best to access some of this data moving forward. And you talked about sort of the platform being built out, but could you talk a little bit about how people could access it?
Yeah, absolutely. So if you go to airbornesnowobservatories.com, by the way, ASO.com was already taken, or we would have that. And go to data, that's where the 2020 data products are from last winter spring. We have all of the data now from the NASA years, and in the effort with Esri, we're working toward getting those to be fully available. If you want to access the legacy data sets right now, you can go to nsidc.org. In fact, can I put this into chat? I think I can.
You
Yep.
should be able
Should
to.
be able to. Yeah.
Okay. To everyone, nsidc.org/data. And that will that'll give you access to those older data sets, but it won't be as complete as what we're heading toward in the build out with Esri. So right now you're catching us right in that transition period, but a lot of the data products are at NSIDC. And if you want to have access to some of the products, or you can't find what you're after, then feel free to send me an email, and or via the website you can find the right person to get you access to the data.
If I might, let me ask a companion question. This one's from Christine Johnson, and she says, what preparations and new processes were necessary for the various users of the survey data to incorporate in their management and supply decision making? So this is moving from accessing the data to what tools do you need and
Yes.
systems.
Yeah, that's a great question. We put together, we plucked the holy grail of snow hydrology. We finally mapped full basin spatial distribution of snow water equivalent and had snow albedo accompanying it, and we gleefully turned it over to the water managers, and they looked at us with some enthusiasm and then said, what the hell are we supposed to do with this? And the analogy that I like to use is that of the iPod. And many of us are old enough, I think, to remember pre-iPod, and in fact, Sony Walkman, and even before that. But before we had the iPod and iTunes, we had MP3 players. And with those, you had to take your own CDs, put them in the tray, and then burn that onto your directories. You had to have your own directory structure to be able to somehow pull that over into your MP3 player. It was just kind of a mess. And the big advancement that came was arguably iTunes, where all of a sudden you could access the data easily, and you could drop them into your iPod easily, and it could be organized well. And so what they did is they went and mowed down those obstacles. And so what we've been working on with the various water managers is either helping support them as they build up their own structures. So I showed the results of the assimilation in the PRMS model that Hetch Hetchy is doing. And then those April through July runoff forecasts that are built on the flow versus ASO data. And then what we're headed towards in that work with the National Center for Atmospheric Research is to provide a modeling structure that can best use that spatial distribution, not only of snow water equivalent, but also the snow albedo, and have that into snowpack forcing, snow melt, and likewise the flow routing. So the end to end. So it was an interesting and fascinating process to watch, as we were supremely focused on getting ourselves to rapid turnaround of the snow water equivalent products, and then throwing them through the internet to our customers, and then having to go through those conversations to figure out how best to use them. But what we're seeing now, the literature is getting richer and richer with the applications of the data, the assimilation in distributed modeling, snowpack modeling, as well as hydrologic modeling, and ecosystem modeling. So we're right at the beginning of it. And as I described with the hydroelectric side, Wes and I were on the phone earlier today, and this is really scratching the surface. But there has been some passive optimization of hydroelectric with these data, but where we really need to head in this world of specialization and optimization is an active optimization, to really get to greater granularity with that improvement of the hydroelectric side, as well as ecosystem and water supply and operations.
Well, with that, I'm going to say thank you to everyone, and we'll sort of end the formal piece of this. A huge thank you to Tom for being here today, and for all of you for attending and for the great questions and the like. So thank you. And then we'll open things up for sort of a less formal discussion, as it were, and let's give it a try and see how it goes.
All right.
Perfect.
Thanks, Tara. I'm going to take the mute controls off so people can unmute themselves. Do we want to keep recording this Q&A portion, or do you want me to end the recording here?
Let's keep it running for now, Amanda.
All right, well, I got a thumbs up. So all right, there we go. So folks, if you want, you can now unmute yourselves if you have some questions for Tom.
I'm going to kick off one more question while the group is kind of figuring out how they want to jump in. Tim Hutchins asks, will more accurate data allow the adjustment of water year types into more categories?
I'm going to have to defer on that. I mean, for me, I look at this as continuous, and the discretization of year types makes me feel like we're not using the full value of the data. And so my preference is that we're running physically based models, and we're constraining with the most accurate data that we can. But I also realize that from management as well as legislative processes, discretization like that is going to happen at times for threshold decisions. But absolutely, I think the data are there to be able to get to greater granularity.
Can I add to Tom's comment? This is Peter Vorster. And since I'm involved in the San Juan Creek River Restoration Program, I'll speak directly to that question. As Tom said, it's actually one of the holy grails in environmental flow management is the challenge of the year types. And, if you're on one side or the other, and can you trust the forecast and all that? This gives us more trust in the forecast. And in fact, the restoration program specifically called out in the settlement to transform the step hydrograph into a continuous line. And so then with ASO coming a few years later, it was like, okay, that's making that life easier. But I agree with Tom, there are certain thresholds that we still have on the upper and lower ends. But this actually, year types can go away, which I think will be, that combined with, the water board, let's say, using unimpaired flow or whatever other methods to get away from year types. This is a huge, huge, I think, bonus for everyone on all sides.
I think everybody's unmuted, so if you want, you can raise your hand and maybe Tara can call on you, but otherwise jump in with questions.
See, Trevor has his hand raised. Trevor, you want to go ahead?
I was always good at doing that in class, raising my hand. It's great they have a button for it now. Hey, I jumped on a little late, so I apologize if you already covered this. I'm kind of jumping on board this hydrologic modeling and trying to learn as much as I possibly can. And I guess I'm interested in other data sets that you're using, I believe for snow covered area estimation, which I believe goes into SWE, starting off at elementary here, but like MODIS and Landsat. And I'm wondering if there's any limitations that you would desire to overcome, you know, high resolution or greater frequency. Thanks.
Yeah, so that's a good question. I'm glad you mentioned it because I didn't cover that, but some of you may be aware of the snow water equivalent reconstruction product that Noah Malich's team at the University of Colorado is producing, and my snow covered area retrievals from MODIS, which is a 500-meter NASA retrieval, get fed into that in a near real time basis, and the value of that kind of work is that it's able to get a daily resolved snowpack with some observation, but it's snow covered area. Snow covered area itself doesn't tell you snow water equivalent, and so there's considerable uncertainties in those products day to day. But as we move forward with this program, with the ASO updates themselves of spatial distribution of snow water equivalent with the kind of accuracy that we have, that will then be able to bring some of those other remote sensing based products into alignment. And so the anchor for those will be these ASO measurements. But those will then, those satellite products will be able to carry it in between acquisitions to a degree. I do want to mention that we are also this year going to be using the European Space Agency's Sentinel spacecraft, as well as Landsat, those acquisitions at 20 to 30 meter resolution to constrain the snow covered area on our modeling. We get very accurate snow covered area with the ASO at 1.5 meter measurement on the ground. So we don't need it for that, but for the modeling as we continue on between ASO acquisitions, then we can update the model's spatial extent with those satellite products. So it's for those of you who are young, you have waded into an embarrassment of riches here for being able to do your work and to have water management change. There's a lot of angst, rightly so, about climate change, but at least over on this side, we're getting the tools put together that are going to allow us to be far more accurate and far more robust with our forecasting and our knowledge of those natural resources. Next question.
I have a question, but I can't see this hand. I don't have a hand to raise here.
Then raise your hand, Peter. I can see you.
I'll raise my hand. Tom, having worked with agencies who jumped on board and the Front Water Authority and the restoration program jumped early because we saw the value of it. Others have been slower. They say, well, budget limitations, prevent me from, I like my cloud seeding program, or I want to invest in this highfalutin, academic climate change, physical based modeling. How do you overcome the resistance to you like what you have, or you're used to it? This is a new way of bringing in information, and it's not an either. I mean, I sense that they think it's an either or. How do you overcome that hurdle?
So we had a lot more of that at the beginning. So back almost a decade ago, and we have a whole lot less of that now, and that's in large part because of the case studies that we've developed over this last decade with the likes of you and Wes and Chris Graham and Chad Moore and Denver Water, and even in Switzerland as well. And but the one thing that keeps coming up is people initially say, well, maybe we can maybe we can fly and just have some strips of data in there, and so you're getting a lot more measurements than you'd have with snow pillows and snow courses, but you don't have the full expense of that. It would be so awesome if it was free, like the satellite data. And so I have to point out to them that satellite data, that's actually not free. Turns out those are like the Landsat program is a $1 billion build, and that's a whole lot of planes with lidars flying all over, and so what that comes back to then is the push that we've been seeing with Senate Bill 487 and its phoenix that's hopefully rising from the ashes, and then the federal legislation, is that this is moving towards that same kind of model of that the satellite program has, or the USGS stream gauging, or the NRCS with the SNOTEL. And so once we explain that to them, that really seems to ease their emotional burden going into it. And likewise, when we show them the results of the return on investment, what it really does, and how it is not that you are anymore going to be uncertain and thinking you know what type of year it is. You're going to know to within about 1% to 2% how much water there is in the snowpack up in the basin, and based on these relationships, how much of that you're going to get into Hetch Hetchy, you're going to get into the various reservoirs. And so it's becoming easier and easier, and I think the more that people are able to peer over into various basins, and then the other thing is that we have advocates for the program. You are a very outspoken one of those. Wes Moynier is, Steve Haugen is, and tons of other people. And the other aspect is the openness from DWR from the very beginning. So we had funding. Martha, that was really nice of you, by the way, to quote Frank early on. Frank and I had known each other. Frank Gerke, for those of you who don't know, was the chief of the California Cooperative Snow Survey Program for some decades, and he was the California snow groundhog that you would see every April 1 out there at the Phillips Survey, and he believed in us from the very beginning, and he worked on getting us water bond funds to supplement what NASA was putting in, and that really helped get us across the threshold. And having that forward-looking agency was absolutely critical to getting to where we are right now, and it helped us to springboard into Colorado with the Colorado Water Conservation Board. And we had Joe Busto was a similar personality to Frank, and ultimately an advocate. And so that's a long answer, and it's one that actually I could go on for hours and hours as I work through each person that's been involved with helping move this forward. And not least of which is, of course, the ASO team, being able to realize this, to overcome so many of the naysayers who said there is no way that you're going to pull together a terabyte of data with a flight with dual instruments. You're going to weave those together and you're going to punch those out in 24 to 72 hours. Absolutely no way. And including some of our own team members who said that at the beginning, and now we're at just an amazing place because of their efforts.
Thank you, Tom. We have a question from John, and then a couple more questions in the chat that we can turn to after John. John, you want to go ahead?
Yeah, great. My question is on the, is there number one, is there a data catalog of what flights and what previous years of data there are and the dates? And the reason that I'm asking is around looking at the effect of fire on snowmelt time and things like that in burn scars, or if you are aware of work that's already happening with that.
Yeah, so we the full data catalog table of contents, if you will, is you can access a form of that at NSIDC. And then likewise, if you email us, we can get that to you, and you can have that stratified by basin, and it'll have the actual acquisition dates, et cetera. And then our full build out with the data system will of course end up having that time series available.
Are you aware of any post-fire from previous years? I mean, I know the Creek Fire is this year, so we'll be gathering some information from that. But you know, Rim
Hopefully
Fire.
tomorrow.
Hopefully tomorrow. There we go.
Yeah. So I believe in the Tuolumne and the Merced, we have post-fire acquisitions from the fires that I think they were 3 years ago, burning up towards Glacier Point. I can't even remember anymore the names of the fires. There's so many of them.
Great. Thank you. Question from David Curtis asks, what are the challenges for this in more heavily forested areas dominated by snow?
That's a great question. So we have flown up on the Olympic Peninsula in Washington, and wow, that was a challenge because of the number of the number of scattering events of the laser pulse, making it really hard to get to ground level. And so in those really dense settings, it can be a challenge to get to the substrate. On the other hand, it's also a challenge for the snowflakes. In fact, even more of a challenge for snowflakes to get to the bottom of that substrate. So some of our burden is eased by that. But from a technology standpoint, our LiDAR provider is Regal, and they're out of a little village in northern Austria. We've worked with them over the years. In fact, we bought their first dual laser system at NASA, unit number 1, which usually is a very scary thing to do, but because the quality of these was so good, we were happy with it. But we've been working with them on being able to get us higher and faster so that we can capture, when we get a short high pressure window over the Sierra, we want to get that snapshot as fast as we can. And if we're having to fly low and slow, then we run the risk of losing that window. And so they listen to us, and so the LiDAR that we have coming here in the next 2 weeks to Mammoth that we'll be integrating in the plane is a double powered laser with a higher pulse frequency. And so what that means is that you can fly higher and still have that power, and still have even more power than you had before with the previous versions. And likewise, fly faster, and that pulse frequency being higher than what we've had before allows us to keep the kind of spatial density on the ground. So, you know, if we had started this 30 years ago, we would have moved on to something else because the technology was not going to be there. And the technological developments that happened over the last decade are also, those have also been key to realizing this opportunity. And we are starting to roll off. I mean, we are starting to get toward some of the asymptotes in the physics and the technology. And I should mention that you didn't ask exactly about this at all, but when I was at JPL, I led the JPL formulation program for a spaceborne version of this, either LiDAR or radar, and we'll get there with something, but the physical limitations are a barrier to being able to do this accurately from space. And so that was what gave me the confidence that I'm going to be long dead before there will be a spaceborne program that can do anything nearly as accurate and fine resolution as what the airborne LiDAR and spectrometer program does. And that's why I made the decision to leave my NASA scientist position to start a public benefit corporation and offend my sons by becoming a businessman. They're 14 and 11, so they're not that offended.
Kevin Mitchell, who is a GIS specialist for Fresno Irrigation District, asks, what is the ultimate goal for ASO in a temporal resolution for individual river basins?
That's a great question. So the nominal program right now is monthly during the accumulation season, January, February, March, April 1, and then biweekly thereafter. That said, the discussions that we've been having with DWR, as well as the cooperators in California, as well as in Colorado, and even in New Zealand and in Scandinavia, they're starting to move to, we want to be a little bit more nimble in the accumulation season. So perhaps we get a January 1 acquisition, but we get a monster series of atmospheric rivers in the first half of January. Do you want to wait until February 1, or do you want to fly hot on the heels of that? And so there's a lot of interest in seeing if that slider bar on time can be adapted. So it's still up in the air, but the nominal program right now is this roughly 10 acquisition program through the winter and spring.
Excellent. Are there other questions?
Well, I'm going to speak up again. I can't find the hand raising, but Tom, talk about how you are integrating with the California LiDAR program, one, and and then more specifically, how, given right now what your product is primarily being used for, water users, but we have this, possibility of public funding. How this whole idea of beneficiary pays is, very, very alive. And so, can you envision a program where the state and federal government are putting money in, but the water users who are truly valuing it are also contributing? I know that's not a science question, that's a policy question, but the reason why I asked how you're integrating with California LiDAR program, because I think it's you're doing all this stuff, and as you said earlier, some of the stuff they take, their LiDAR surveys take months to process. So is there a jealousy factor there?
No. So again, we fly at 1 point per square meter in our snow on surveys, and the California LiDAR program is going to be flying 8 points or better per square meter really have that full characterization of the forest canopy, as well as shrubs and beyond. And so going back a little bit to the history of how the California LiDAR program emerged, obviously there'd been interest for a long time in having a full survey of the state with LiDAR, and but there were some folks in the Sierra Nevada Conservancy. Liz Van Wagtendonk is one in particular, and others who started talking with us about the bridging between the two. And just to keep it fairly short, the concept is to have these benchmark high resolution surveys from the California LiDAR program. So an 8 points or better per square meter survey, and do that once a decade, say every 5 years or every 10 years. And as a census of the ecosystems of California. And then for that part that is being driven by snowmelt and hydrology, those areas that are being driven by the funding for hydrology, we can capture, as I showed, we can capture those time series of data and fuse those into higher resolution products, slightly more uncertain, but from that fusion, but still they can be anchored by those benchmark surveys, those much higher resolution surveys, and that can affect then an annual survey of those ecosystems, of those forests, of those biomes, and so this is I think it's inevitable that we're headed here, and for the snowpack measurements and the kind of temporal resolution we have, and likewise for the California LiDAR program moving ahead. For instance, the state of Colorado is now completely covered with high resolution LiDAR data. I'm not sure all of the data are available yet, but they are in either available or in the can going through processing. So the relationship with the California LiDAR program and Department of Conservation is a very happy one, and an exciting one for going forward. And it's really one in which we're going to be opening up the eyes of agencies and municipalities and the feds and arguably the entire public of California and beyond with these kinds of combined measurements.
Wow.
Yeah. Great.
I think that's a great ending note for this presentation. Don't you, Tara?
I do. Yeah. What a wonderful, also, yeah, what a wonderful way to end this, Tom, is with this sort of less formal discussion. So appreciate both you sticking around as well as everyone who stayed to ask questions and the like. Yeah.
Those who know me well know I could sit here for until midnight tonight. So
That's why Tom and I should never be in the same room.
ever.
Amanda's in control. She can just end this whenever necessary.
Let me just say though that if you have more questions and you want to know and you're not finding what you want on the website, please do send me an email, because we are in that ramp up. So not everything is there yet. And you can also click on some of the links as to future releases of the tools. So for instance, the data system, and then you'll be in our list of people to communicate to when that comes out. So
Perfect. Well, thank you, Tom, for being here. Thank you, Martha, for setting this all up, organizing it. And thank you for everyone for being here. As I mentioned at the beginning, we will have Tom's both slides available as well as the recording of the presentation available on our website shortly. So we'll send out an email letting people know when that's available. But thank you.
Thanks for having me.
Thank
Bye,
you,
all.
Tom.